Hey there, Dango Stu here. In today's video we're going to be putting the crankshaft into the Evinrude 150. Before we do that though, I've got another viewer t-shirt photo. This one's Ron Powell from Sydney in front of his own boat. This is a photo from when he came down and we had a bit of a look at his carbs for him, so it was nice to meet him. Alright, so we'll run up on the board and get going with this crankshaft. When I read through the procedure in the service manual for installing the crankshaft in this motor, it seems to rely heavily on using an Evinrude custom tool, a end cap aligning tool. So these are the end caps that go on the conrods and the big end bearings go in the middle here. But having done a bit of homework, I realised that a lot of people actually just literally feel along the end cap with their fingernail to make sure that it's perfectly aligned, there isn't even a tiny gap, and say they get really good results with that. I went up to our local Evinrude repair dealer, etc. this morning, and I asked him about this tool, and he actually admitted that he didn't have one either. So I'm pretty comfortable knowing that a lot of people have built a lot of motors successfully by simply really making sure these end caps are so well lined up you can't even feel a gap, to run with that procedure as well. So that's what we're going to be doing today. I think because of this it's going to make it a pretty slow and tedious process, but we'll see how it goes. I'll be curious to see how long it takes all up actually. So what is it now? We'll call it 5 to 1, so we'll see. Alright, first thing I'm going to do though is put some new oil seals onto the crankshaft. For the crankshaft we've got a new upper main seal and a new lower main seal. The lower main seal goes into a housing, so we need to get the old one out. This lower main seal also has an O-ring around the housing, so I'm going to replace that. I'm thinking it's this smaller one here, but I haven't actually fished the old one out yet to compare the size. This one actually looks to be a slightly bigger diameter. I was just looking for the closest match that came in that seal kit I bought. This one's definitely a thicker diameter, so I don't think it's this one. This one's slightly bigger by the looks of it, but it may have just stretched. So I'll give this a bit of a clean up. Actually, I'll pop this old seal out first as well. It looks like there may have been a little bit of sealant on the outside of this seal when it was installed, but I'm just going to pop it in with a little bit of rubber grease. So new seal pushed in now, and I'll just try this new O-ring on for size and see whether it seems right. Yeah, I'd say that's perfect. It's definitely the closest match in the kit and it goes on quite nicely. And I'll also just put the tiniest bit of rubber grease around this O-ring as well. The last thing I do is just put a little bit of this Yamaha grease on the inside of the oil seal, just to give it a little bit of startup lubrication. This top end seal runs along this surface here. So all I'm going to do here is just put a bit of grease on the inside as well. The first step in the process is pushing all the pistons down to top dead center. So just taking all the conrods and pushing them down till the pistons are sort of against the head. Then you're clear to drop this crankshaft in. Now this is the bottom of the motor, so the lower end is going to go that way, so we know which way it goes. The top end is the one that has the shaft for the flywheel to go on. The lower end is the end that has the splines that the drive shaft slots into. Here we've got all the compression rings still on the crankshaft. I'm going to slide this top seal on with the spring side facing inside the motor, the flat side facing outside. The bottom seal I'm popping on with this side that's got a little tab going closest to the motor. This gives us two grooves, the groove of this metal ring of the bearing and the groove here of the seal, and they'll go into these two grooves that I'll show you as we drop it in. So you'll notice one difference from when we dropped this in originally is that the end caps are off the conrods. They're all numbered, so they match very specifically the conrod they come from, so make sure when you take those off they don't get mixed up. In this case I'd stamped matching numbers onto them when they were disassembled. When you drop the crankshaft in, there's a few things you need to get lined up. It doesn't talk about it in the manual, but as far as I can see, this little tab here on the end of this oil seal housing needs to go downwards towards the block here, so it locks into this little hole that stops it rotating. Once it's in there, the housing itself can't rotate and spin. So we want that facing down. These centre bearings have a little hole here, and we need those holes to mate with these little dowels. So we got 1, 2, 3 there for the bearings, and then one hole here in these two grooves. So they're the first things we need to get in. So I'm going to drop this down. Rotate it a smidge. When you go drop the crankshaft down, the first thing you'll find is that 2 of these crankshaft journals will be low down and they'll hit the tops of the conrods. So it's a case of just jiggling it a little bit, jiggling the conrods. So these 2 low ones slot in nicely. These top ones won't interfere with anything, so no problem there. Next thing I'm going to do is just rotate all these compression rings so that the gaps are pointing upwards. We also need to rotate these bearings until those little holes line up with those little dowels. Unfortunately, you can't see either of them once it's in this position, so I can only presume we're looking at the one that's hardest to turn, which in this case is this one, and see if we can get it to drop down. Once it has dropped in, the outer casing of the bearing won't be able to rotate, it'll be locked. This one actually feels locked, so I might try this one next. So there it is there, so it's a fair way out. That one just locked in then. This one's still locked in. This one still feels like it can rotate. One to go. Right, got there. So that's all 3 locked in now. It was fiddly, I've got to say, but what I found myself doing was rotating it till I got 1 to drop in. Then I could actually lift the crankshaft slightly from this end, rotate others until they drop in, and then you could lift it again and rotate the next one. These wouldn't turn, so every time I dropped it down, I found the ones that had previously seated would reseat quite nicely. So in the end, all 3 of those were seated. We're up to cylinder 4 now. So far it's been going reasonably smoothly from an installation point of view, but I'm not sure how well I've been doing with the filming. It's actually a little bit tricky with only 2 arms to film it and show you how this goes together. The basic procedure has been rotate the crankshaft till the journal for the cylinder I'm working on is close to the end of the conrod. Then I've just been putting a bit of oil onto the half of the bearing and then sliding it between the end of the conrod and the crankshaft. Once it's in there, you can get your fingers in and lift the conrod up, or lift the piston up in its bore, until that bearing's pressed firmly against the crankshaft journal. Once that's firmly in place, you can put the top half of the bearing on, give it a little squirt of oil. Then I'm going to take the end cap that matches that conrod, because they're all very closely paired. They're actually made and then broken, so they're an exact match for each other. Then you find the side that's got that little dot there on it. That little dot has to face towards the flywheel. There's actually a matching dot on the conrod, but we know the conrod's round the right way because we had that little oil hole facing the flywheel as well. Next I'm going to grab a couple of these brand new end cap bolts, a little bit of oil on the throttle section, drop those in, and then just do them up finger tight. Once these bolts are done at finger tight, you should be able to run your finger, and in fact even your fingernail, along the end of the rod cap here, where it mates with the journal, and it should feel basically like one piece of metal. If you can feel any sort of ridge, then the rod cap here is misaligned with the conrod that it mates with. So once that's smooth, and these are finger tight, I'll be moving on. I'm going to torque them all up to spec in one sitting, rather than sort of constantly changing the torque wrench setting, etc. But I'll be double checking them all before I start torquing them up properly. Once again, finger tight. I can run my fingernail across there now and just, I can't even feel that gap. So I know they're mated really nicely. That's all 6 done now, so I can rotate the crankshaft now. One of the articles I read on the net said that the person doing this had done 50 or 60 of these motors, never had one fail, and liked to rotate the crankshaft before torquing them up. Felt that somehow it helped it sort of seat a little bit, so I'm happy with that. I also think if anything's really catching, you're having any real problems, you're going to feel it as you rotate this. So this feels pretty good to rotate it. It's not catching in any one place, it's not particularly difficult, particularly given you've got no leverage without the flywheel on. So what I'm going to do now is rotate each one up, double check that it's mated nicely, and then we're going to start torquing these up to a low setting and then keep going through stages till we get to the final torque setting for these end caps. So the service manual says to start with a initial torque of only 5 to 7 Newton meters. So what I'm going to do, this torque wrench doesn't really go that low. My little 1/4 inch does, but I don't have a 1/4 inch socket for these 12.8 mil bolts. So what I'm going to do is actually just put this onto a normal wrench and just go that smidge beyond finger tight and double check that I can't feel any ridge on the end cap. That one still feels really good. Still feels good. I'm not so happy with this one actually. It feels like it's got a little ridge on it. So I'm just going to back it off a little bit. Alright, that one didn't feel that good, so I just took it off and reseated it again. It feels much better now. So now I've got them all torqued up with the end caps still feeling very smooth to just beyond finger tight, to that sort of 5 to 7 Newton meter area. I know I was just using a ratchet for that one because I don't have a socket for my 1/4 inch torque wrench, but I'm pretty confident it's in the ballpark. So now they're firmly connected and very well aligned, I'm going to start torquing them up to this 40 to 43 Newton meter end goal, but in a couple of phases. So I'll sort of go 20, 30, 40, I think, just to make sure they don't get too much force on one side and misalign themselves again. Just having a little bit of a feel of the end caps each time to make sure nothing's slipped or gone wrong as I'm torquing these up. I think we're done with these conrods now. So, feels nice. We've got them all torqued up to the right spec now. We've got the oil seals in for both sides. The middle bearings are all locked on their dowels. The oil seal carrier for the lower ends locked in on its tab. I think we're good to go to put the crankcase on. Before putting this together, I cleaned these mating surfaces of old sealant. That's really important because this crankcase is actually what holds. It's actually the end caps for these center bearings here. So if there was old sealant on here, it would sit a little bit higher, and that would mean that these bearings weren't being held securely. So having this clean is important. During this process, obviously, I've been using a lot of 2-stroke oil to lubricate the bearings for the startup. So I'm going to clean all that off this mating surface here, so when we put the sealant on and put the crankcase on, it's got a nice dry, clean surface to adhere to. Before I put this crankcase on, I'm just going to start squirting a bit of oil, a bit of 2-stroke oil down in between the gap in the compression ring as I rotate the crankshaft. Give that a bit of lubrication. I'm also just going to put a little bit down the gap in the main bearings. Now the instructions for putting the Gel Seal 2, which turns out to be Loctite 518, on here says we're going to use the primer first. So it says to put the primer onto the mating flange of the crankcase, let it air dry, and put the Gel Seal sealant onto the crankcase. So what I'll do is I'll spray this first. But I will rotate each time, so I'm sort of aiming it away. I have no idea how much of this stuff you're supposed to use, but I'm not going to go nuts with it. Alright, so that now needs to air dry, and we'll go and put the master gasket onto the crankcase. What I might do before I put this on is actually just do a little bit of a test fit of the crankcase and just see where the limits of it are. There's no point putting all this gasket in places that the crankcase doesn't even reach. So we've obviously got this zigzag pattern where the inner bolts here are for the crankcase, the outer bolts are for the carburetors to go on. And then we come out across here to the flywheel side. All right. So the important thing from what I can tell is we're looking to seal the crankcase obviously, but avoid having this, as we push the crankcase on, having it migrate into these compression rings or into these bearings. I think this will do, it'll seal it up. There's no way then for gases to get past here and escape. It's got a continuous speed, so let's pop the crankcase on and get the bolts on for that. The instruction now is to run these down lightly. You'll notice each of these sets of bolts, the larger bolts, coincides with a bearing inside. So these are essentially those end caps for the bearings. So just going to do them up very gently. So the next step now is to actually install a taper pin that goes in the crankcase. The next step in the manual now is to install a taper pin that goes in the crankcase. I don't have one of those. I don't want this master gasket to set without doing it up properly. So the hole it goes in is really nicely aligned, so I'm kind of comfortable there. But I am going to push on, torque up these main bolts, and then put all the flange bolts in. So these main bearing bolts now, so we'll start in the middle once again and move outwards. These need to be torqued up to so these main bearing bolts we're going to torque up to 45 Newton meters, but we'll do it in 2 stages once again. So I'll sort of go maybe 30, then 45. Now I'm going to put the bolts in here that hold the flange of the crankcase on. These flange bolts I presume are 3/8, so I'm just using a little 10mm socket because I'm going to use my 1/4 inch torque wrench to torque these up because they've got quite a low torque setting. So these ones get torqued up to 8 Newton meters. Crankshaft still turns nicely, so that's good. It's got enough oil in there, I'd want to. Doesn't feel like it's catching at all. No sort of inconsistencies in the turn, so that's a good start. All right, well that's the crankshaft in. It's best I can do for the manual. Certainly feels good, so I'm pretty happy with that. All right, well thanks for watching. Next step now is to start putting all these ancillary things back on, put the carburetors back on, flywheel, everything, and then drop it back on the power head. So we'll pick up there and I'll see you soon. All right, take care, bye.